Hey everyone, how you doing? Morgan here. We're going to look at a couple of the more challenging homework problems that have been assigned for this chapter. And one of them that I found in here that I thought was really worth trying assigning was number 145, where you have a mixture of copper sulfate, pentahydrate, and magnesium sulfate heptahydrate is heated until all of the water is lost. If 5.020 grams of the mixture gives off 2.988 grams of the anhydrous salt, meaning that's the dry salts, what is the percent by mass of the CuSO4.5H2O in the mixture? So I'm going to pull the book here out of the way and run through as I keep hitting my keyboard there. Sorry about that. I'm going to run through what some of the most important points are for this question and do a bunch of the calculations here with you. It's going to get lined up with the camera all right. Okay, so this is question 145. So we have CuSO4.5H2O, which is a hydrate, and we have MgSO4.7H2O. And when you heat them, they're going to dry. The water's going to be pushed out. Okay? The total mass is 5.020 grams total. That's when you add the two of them together. Okay? Now, what that's saying also in the question is that when you have heated it, you have 2.988 grams of anhydrous or dry salt. So I'm going to say this minus this equals, I'm going to get my calculator here and go 5.020 minus 2.988 equals 2.032 grams of water has been lost. Okay? Now, we're looking for the percentage of CuSO4.5H2O total. Okay? Now, there are a few things that I can do in here that are just typically algebraic. I'm going to say that X equals the mass of CuSO4.5H2O. Okay? Now, that means that the mass of MgSO4.7H2O equals 5.020 grams minus X. Okay? That's just kind of your basic algebra here. Okay? Now, we have your basic system of equations. Now, assuming that the percentages of these two add up to be 100%, which is a safe assumption because those are your only two components inside of this mixture, I can say that the mass of CuSO4.5H2O, okay, times the percent of water in it plus the mass of MgSO4.7H2O times the percent of water in it equals, over here, sorry, 2.032 grams. Because that was discovered up there, calculated up there. Okay. Now, the percent of water in copper sulfate dot 5 H2O is going to equal 5 times 18.02 grams per mole. It's the molar mass of water, divided by 249.7 grams per mole, which is the molar mass of CuSO4.5 H2O, times 100%. So 5 times 18.02 equals, divided by 249.7 equals, times 100% equals, and I'm getting 36.08%. All right. So the percentage of water in MgSO4.7 H2O would equal 7 times 18.02 grams per mole, divided by the molar mass of MgSO4.7 H2O, which is 246.5 grams per mole, times 100%, which is 7 times 18.02 equals, divided by 246.5 times 100, 51.17%. Okay, so those are my percentages. So now, X was my mass of copper sulfate .5 H2O times the percentage, which is 36.08. I'm going to do it as 0.3608 plus, now I'm going to have the mass of the total, 5.020, minus X, which is the amount of the copper sulfate, times the percentage of the water, 0.5117, and that is going to equal the 2.032 grams of the water. Okay, now X is in grams, 5.020 is in grams. So basically I'm saying the percent of water times the mass of the copper sulfate times the percentage of water times the mass of the magnesium sulfate hydrate must equal this amount. I've defined the mass of water in the copper sulfate here, the mass of the total there of the hydrate to be X, which means the mass of the hydrate of magnesium sulfate is 5.020 minus X, because 5.020 is the total mass. That's just that the two of those have to add up to equal the total. Okay, and now I've taken that equation and I've put it together with that equation, using this for substitutions, okay, and I've solved this system of equations. So 0.3608x plus, I'm going to do this times this, 5.020 times 0.5117, and I get 2.5687. That has no X in it, minus 0.5117x. Now, this is in grams. This has grams on it. Okay. I'm sorry, this times this has grams in it, and 5, boom, 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 get that off, okay, equals 2.032. Actually, they all have grams in them. They all have grams. 2.032 grams. Okay, now I'm going to have to group some like terms here. Now, the simplest thing in my mind, I think, is going to be to move this to the other side because it's a little bit bigger than that, and to bring this over to that side. So 2.5687 grams minus this one, 2.032 grams, equals 0.5117 x grams minus 0.3608 x in grams. Okay. Now, hold on 1 second here. All right. Now, I got to do this. 2.5687 minus 2.032 equals 0.5367 grams equals 0.5117 minus 0.3608 equals 0.1509 x, which is measured in grams. So I have 0.5367 divided by 0.1509 equals x, which equals 3.5566, 3.557 grams CuSO4.5 H2O. So what I can then say is 3.557 grams out of the total, which is 5.020 grams, times 100% would equal 0.57 divided by 5.020 equals times 100, and I get 70.86% of this is the copper sulfate dot 5 H2O. Okay? So now, I have not looked in the back of the book yet. Okay, if this is in the back of the book, probably not. But I'm assuming I'm pretty close to being right there. Okay? So there you go. That's a systems of equations. I chose the problem because it is a challenging algebra problem, and it was something quite similar algebraically on last year's chemistry Olympiad. Okay, now, the next one that I sent your way that was similar in challenge was question number 152. Okay, bring this back over here. Air is a mixture of many gases. However, in calculating its molar mass, we need only consider the three major components: nitrogen, oxygen, and argon. Given that 1 mole of air at sea level is made up of 78.08% nitrogen, 20.95% oxygen, and 0.97% argon, what is the molar mass of air? Okay, So, let's do these molar masses. The molecular weight of air is going to equal, first off, the nitrogen, 78.08. So 0.7808 times 28 point, well, let's check this out. Typically we say 14.0. Let me check what this book's periodic table is saying for nitrogen. Okay, just checking. This is saying 14.01. Okay, so 14.01 times 2, you get 28.02. Just going to match this book for you. And that's in grams per mole. Remember, the nitrogen's diatomic. Plus 0 point. Now, for the oxygen, it's saying 0.2095. 0.2095 times 32.00 gram per mole plus, now it's really low for the nitrogen, 0.97%, which is 0.0097, for the argon, sorry. Now most books have argon at 39.95. Yep, matches the table on this one, 39.95 grams per mole. It's a new book, just need to check the table. All right, so 0.7808 times 28.02 equals, plus parentheses, 0.2095 times 32, close parentheses, plus, open parentheses, 0.0097 times 39.95, close parentheses, and I'm getting 28.9695. So let's call it 28.97. So it's about 28.97 grams per mole. Okay? And I thought that was a good question also. I was pretty fond of that one. Okay? Now, I also thought a good mathematical challenge for you would be question 162. Okay? Bring the book back over here. 162. A certain metal M forms a bromide containing 53.79% bromine by mass. Okay? What is the chemical formula of the compound? 53.79% bromine. All right? So, first things first. Let's assume it's a 100-gram sample. And let's assume that it's either going to be MBr, MBr2, or MBr3, because bromine is really only going to do a -1 in any of these instances. So let's play around here. Let's find some mole ratios and get some molar masses. So 53.79 grams bromine, assuming it's a 100-gram sample, times 1 mole of bromine at, and it's basically 79.90. So 79.90 grams of bromine equals, so 53.79 divided by 79.9, boom. And I'm getting 0.6732, 0.6732 moles of Br. Okay? So now, if that being the case, I would have, for MBr, 0.6732 moles of M. Okay? Because it's a 1-to-1 ratio. Now, take 100 minus 53.79 100 minus 53.79 equals 46.21 grams. So 46.21 grams divided by 0.6732 moles. 0.6732. Now that's 68.64 grams per mole. So what you do at this point is you start poring over the periodic table and looking for something that's a metal that has a molar mass of 68.64. Now, what I did, this periodic table right here, 68.64, I start looking, and it's not happening. I go from 65.39 to 69, and it's not happening. Sorry. Not gonna work. Now, what if it was MBR2? If it was MBR2, I would have 46.21 grams of M divided by, now I'd have half as many moles of bromine. Okay, if you think about it, it's BR2. So the rate, I said the wrong, I'd have half as many moles as M. Okay, because it'd be twice as many moles of bromine as there would be of metal. So I take the 0.6732 and I divide by 2. That's 0.3366. So divide by 0.3366 moles. Okay? So 46.21 divided by 0.3366. Now that gives me 137.3. Ka-ching. I actually recognize that number. That's barium. Okay? That is the molar mass of barium. And, see right there, barium. Okay? What makes it even sweeter is that I know that barium is a 2+, okay? Which would mean MBR2 is working out for this. And I could go through and do this for the 3+ also, but the element doesn't exist, it wouldn't come out to work for me. Okay? So that's how you do question 152. All right, I thought it would be cool if you actually had video of these 3 relatively hard problems so that you kind of knew what was going on with those. You can go back and look them over more than once. Okay, this is Morgan, signing off.